When working with three-way switches, it's essential to understand how the traveler wires contribute to the junction box fill calculation. Even though only one of the two traveler wires between the three-way switches will be actively carrying current at any given moment, both wires must be counted when determining the required size of the junction box. The National Electrical Code, or NEC, specifies the rules for calculating box fill to ensure safe and reliable electrical connections. A junction box's capacity is determined by its volume, typically expressed in cubic inches. The code mandates that boxes not be overfilled to prevent overheating, damage to conductors, and potential fire hazards. To calculate the box fill, you must consider several factors, including the number of conductors, the number of device yokes, any internal cable clamps, and any equipment grounding conductors. Firstly, each conductor that originates and terminates within the box is counted. This includes all hot, neutral, and traveler wires. Secondly, conductor fill is determined by the size of the conductors. Each conductor size is assigned a specific volume as per NEC Table 314.16. This table specifies the volume allowance for conductors ranging from number 14 American wire gauge to larger sizes. For example, a number 14 American wire gauge conductor requires 2 cubic inches, a number 12 American wire gauge conductor requires 2.25 cubic inches, a number 10 American wire gauge conductor requires 2.5 cubic inches, a number 8 American wire gauge conductor requires 3 cubic inches, and a number 6 American wire gauge conductor requires 5 cubic inches. Thirdly, any conductor that passes through the box without a termination or a splice is counted as one conductor. This is because it still occupies space within the box. Fourthly, device fill must be considered. For each device yoke, such as a switch or receptacle, a deduction is made from the box volume. This deduction is equivalent to twice the volume allowance of the largest conductor connected to the device. For example, if the largest conductor connected to a switch is number 12 American wire gauge, then 2 times 2.25 cubic inches or 4.5 cubic inches is deducted from the box volume. Fifthly, equipment grounding conductors are accounted for. All equipment grounding conductors entering the box are collectively counted as a single conductor based on the largest equipment grounding conductor present. For instance, if you have 3 number 12 American wire gauge equipment grounding conductors, they are counted as one number 12 American wire gauge conductor, using the 2.25 cubic inch allowance. Sixthly, internal cable clamps, if present, are counted as one conductor based on the largest conductor entering the box through the clamp. If multiple cable clamps are present, they are still counted as only one conductor. Seventhly, any fixture studs or hickers also require a deduction from the box volume. This deduction is based on the volume allowance of the largest conductor entering the box. Let's consider a practical example. Suppose you have a junction box containing the following wires: 4 number 12 American wire gauge conductors, 2 number 14 American wire gauge conductors, 3 number 12 American wire gauge equipment grounding conductors, 1 internal cable clamp, and 1 switch. Firstly, the 4 number 12 American wire gauge conductors contribute 4 times 2.25 cubic inches, or 9 cubic inches. Secondly, the 2 number 14 American wire gauge conductors contribute 2 times 2 cubic inches, or 4 cubic inches. Thirdly, the 3 number 12 American wire gauge equipment grounding conductors are counted as 1 number 12 American wire gauge conductor, contributing 2.25 cubic inches. Fourthly, the internal cable clamp is counted as 1 number 12 American wire gauge conductor, contributing 2.25 cubic inches. Fifthly, the switch requires a deduction of twice the volume allowance of the largest conductor connected to it. If we assume the switch is wired with number 12 American wire gauge conductors, then the deduction is 2 times 2.25 cubic inches, or 4.5 cubic inches. Therefore, the total box fill required is 9 cubic inches, plus 4 cubic inches, plus 2.25 cubic inches, plus 2.25 cubic inches, plus 4.5 cubic inches, which equals 22 cubic inches. The junction box must have a minimum volume of 22 cubic inches to meet the code requirements. In the context of three-way switches, it is crucial to remember that the traveler wires are treated as current carrying conductors. Because these wires are an integral part of the switching circuit, they must be included in the box fill calculation, irrespective of whether both are energized concurrently. Ignoring the traveler wires can lead to underestimating the required box size, which can create unsafe conditions. Always refer to the National Electrical Code, or NEC, and local codes for specific requirements and regulations regarding box fill calculations. These codes provide detailed guidelines to ensure that electrical installations are performed safely and in compliance with industry standards. Understanding the principles of box fill calculation is essential for any electrician or electrical professional. Accurate calculations ensure that electrical connections are safe, reliable, and compliant with applicable codes. Furthermore, proper box sizing helps to prevent overheating, reduces the risk of electrical fires, and extends the lifespan of electrical components. When in doubt, it is always best to consult with a qualified electrical inspector or engineer to ensure that your electrical installations meet all applicable requirements. They can provide expert guidance and ensure that your work is safe and compliant with all relevant codes and regulations. Remember, electrical safety is paramount, and proper box fill calculation is a critical aspect of safe electrical installations. Taking the time to accurately calculate box fill ensures the safety and reliability of electrical systems. The number and size of conductors, the number of devices, and the presence of cable clamps and grounding conductors all play a role in determining the appropriate box size. Always consult the National Electrical Code, or NEC, and local codes for specific requirements and regulations in your area. In summary, when splicing the travelers of a three-way switch in a junction box, both wires are indeed counted in the box's capacity, even though only one pair will carry current at a time. This is a fundamental aspect of box fill calculation and ensures the safety and reliability of the electrical installation. By accurately accounting for all conductors and devices in the box, you can ensure that your electrical work meets code requirements and provides a safe and reliable electrical system.